So here we're going to do a set and drift case 2. These are on page 18. So first order of business here is going to be to plot our 0947 position. So that is what we will now do. And that's 41, 15, 9. So we're going to bring 41, 15, 9 over to this meridian here, because we know it's going to be close. So we see it 41.7. So it's obvious which one is going to be the closest. Now we're going to find 41.7. So we got 41, 7. We're going to bring our longitude down here to this parallel. Next, what we're going to do, we've got our 0947 plotted. 0947. So we will write the time next to our start position. So next order of business is to figure out where we want to steer. Where are we going? Well, that's given here. It says we are on course 182 per standard magnetic compass. Before we draw a line on our chart, we are going to be converting 182 to true. So that is going to be next step. So 182 is going to go over here under compass, and then we'll find our deviation for a heading of 182, and that's going to be about 2 degrees west. We'll subtract west while going right or left here. 180. Variation is 15 west. And that gives us 165. So now we know what direction we need to draw our DR track. DR stands for dead reckoned track. So we're going to find 165 on our triangle here. And then we're going to bring our working edge over to our 0947 position. And we're going to lay down our DR track. Now, we need to figure out how far down this line we are going to be at 1020. And we can do that easily by plugging our speed and time in to our 60D street. So distance is what we're trying to figure out. We'll put a question mark by distance. So we know we're only looking for time and speed. So the time is 09:47 start, 10:20 end. That gives us 33 minutes. So we'll put 33 for our time. Our speed is going to be 11.3 knots. So we're going to go speed 11.3 times time 33. Carry this over, and we'll be dividing that by 60. And we get 6.2. So in 33 minutes, traveling 11.3 knots, we should cover 6.2 miles. So now what we're going to do is measure out 6.2 with our dividers, or we can use the scale on our triangle. And we are going to put our dead reckon position. And we're going to indicate that with a semicircle. That is our dead reckon position. So we reckon we'll be right here at 10:20. But Mother Nature probably has different plans in store for us. So now we're going to fast forward. The time is 10:20. And we're going to plot this position. Okay, so this is going to be our actual position at 10:20. Now, what we need to do is figure out what the current did to us. So we should have been here, we wound up here. That means the current pushed us in this direction. What direction exactly is that? Now, we are about to figure that part of this out. And we find that to be 229. So 220, 230. So that's 225, 6, 7, 8, 9. And we'll write that down. And what was the speed with which Mother Nature had to have been pushing us for us to cover this distance in 33 minutes? That is what we're going to figure out next. So we're going to set up another time, speed, distance equation. 60 D Street, time, speed, distance. So time, that hasn't changed. That's 33 minutes. Speed we'll put a question mark there. Distance, we can simply measure that. And that comes out to 1.1. So we're just going to plug some numbers in here. 60 times 1.1 divided by the time of 33. So 60 times 1.1 equals 66. 66 divided by 33 equals 2. And that is our speed. So our speed is 2. We're going to put that here. So the current pushed us in the direction of 229 degrees at 2 knots. That is our final answer. And now we'll see if there's anything in our answer selection that looks close to that. And it looks like we got it right on the money. That rarely happens. We got lucky.